Okay, guys, so let's go over both drills together. Drill number 1 are the topics on your first part of your quiz. It is no calculator. You will be taking both of the quizzes at the end of class. When you get the first quiz, all calculators are put away, and it's just the basic of rewriting and solving. So let's take a look here. Rewrite the following from exponential to log form. You don't have to solve. So log comes first. Remember, the base is the little guy. So log base x, and then you do the loop of y equals 4. There's your answer. That's it. Number 2, I'm asking you to go in reverse order. So you don't have to solve for x. I just want you to rewrite it as an exponent form. So you start with your base, raise it to that power, equals x. And that's it. That's all you had to do. Now for 3, 4, and 5, I do want you to solve, okay, for x. So the easiest way to do that is to evaluate and do the loop method. So starting with the base of 4, 4 to what power makes 64? Well, I hope you have that memory. You should. By now we've done it a lot. X equals 3. Same concept for number 4. 5 is the base to the 0 power equals what? Anything to the 0 power is 1. This 3 to what power equals 1 over 27. In this case, okay, here, well, it's flipped because we know 3 to the 3rd power is 27. So for this to be the reciprocal, your answer is going to have to be a negative 3. Now let's talk about estimating and using the property of log here. It says, which of the following consecutive integers values are the expression of log base 5 of 5 to the 7/3? Now remember, we talked about these in our notes a couple classes ago. A little shortcut with log properties is when you have the base of log and you have a power with the base that's the same, these will cancel each other out essentially, and the shortcut would be you're left with this number at the end. Well, this number clearly isn't a whole number. So I'm asking you, between what integers would it be in between? So if we were to kind of divide, 7 divided by 3 is 2.33. So that clearly shows it's going to have to be between 2 and 3. So number 7, if you were to write these with the change of base formula, and meaning you were to type it in the calculator to give me a decimal exponent, you don't have to. How would you do it? So remember, it would be log 11 divided by log 5. You always divide with the base, whatever the base is. And again, the reason why they said it's a base of 10, because when you split up the two logs, this right now has a base of 10, and this does, like common log. But don't let the verbiage trick you. Here, examine this equation. Between what two integers does y lie in? So the easiest way, you're just doing an estimating, is write an exponent. 3 to what power makes 32? Clearly, again, that's a decimal. I don't want the decimal, I just want to know between what two whole numbers. So if you kind of go, okay, 3 to the 3rd is 27, 3 to the 4th is 81, you can clearly see this answer is going to have to be between 3 and 4, because 32 would lie in between here. So I would say between 3 and 4. So for your first quiz at the end of class, when we do them, you're going to be expected, no calculator, to do these basic stuff of logs. Okay, we also reviewed it last class, and we've been doing logs for a little bit now. Now let's look at the equations. So drill number 2 is the equations. We reviewed these as well. Let's take a look at what you would do. You can use a calculator on this quiz as well. So after you do your no calculator quiz, you will turn that in. You will get this one, and you can use a calculator. So this has a log in it. So the only way to do it is to do the loop. but you cannot do the loop until you get this by itself. So the first step I'm going to do is divide by 25. And then I get my log base 2 of x minus 4 equals 3. From there, now that you have the log isolated by itself, the only way to solve it is to write it as its inverse, which is by doing the loop, you do exponential. So 2 to the third power equals x minus 4. Okay, so by doing this, you have 2 to the third power is 8. And then you add the 4, so x equals 12. Now, if you wanted to on the quiz, guys, and if you don't have a calculator, you're going to have to leave your answers in exact form. You're not getting a calculator, because clearly I'm not here. You're going to have to leave it if you needed to. Let's say you couldn't do it. You could leave your answer like this if you wanted, guys, okay? If you don't have a calculator. Let's take a look at 2. This is another log, but it's a natural log. Remember, the base of natural log's e. They're never going to write that. So we do the loop, e to exponential form to the fourth power equals x plus 3. And then, again, you could type this in your calculator and get the decimal, or you can leave it exact, especially if you don't have a calculator today. And there's your answer, e to the fourth power minus 3, or you can type it in the calculator, and there's your answer. Completely up to you. Okay, oh, a little dull there. So let's go on to the 2e problems. These are exponential, so you will be using the natural log. Now, this is already isolated, this isn't. And you had something like this on the Kahoot, I'm sorry, the quizzes. Now, let's take a look at this one first. Since this base is already isolated, we're just going to multiply both sides by ln. Then, that is what evokes the power rule that we talked about a couple classes ago. The power rule of logs is that comes in front, so it's 3x times ln of e, like so. Then, well, remember, ln of e actually makes 1 anyway, so you can cross that off. And then you can just divide. Now, you could type this in your calculator, as I've been saying, or you're welcome to leave it like this. If you did type it in your calculator, it would look like this. So ln of 7, and then divide by 3. It is completely your call. I'm fine with exact. So if you don't have a calculator today, so you're going to have to do it in exact form. Same thing, let's look at here, except now you have to get rid of the 10 and the negative 2, because this is the base, and then there's the exponent with the power. So, you need to get that isolated before doing ln. So I'm going to subtract 10 first. Then the opposite of multiplying by negative 2 is dividing. So I'm going to divide by negative 2. Now you have the base, okay, and the exponent isolated. I could do the ln of both sides. So I'm going to multiply both sides by ln. By doing that, that creates the power rule here. Power rule comes in front. So x minus 3 times ln e. So then this will cancel each other. I mean, that makes 1 anyway, I should say. So then all you have to do is add it over. So ln 1 plus 3 equals x. That's exact form. Well, really, to be honest, guys, exact form, ln of 1, anything to what power makes 1 is 0. So really, your answer is 3. So last but not least, we have exponential. First thing, though, is You could use a log since you have a calculator, but it looks like to here, I'm going to use the option 1, like station 1, and I'm going to have a common base. Now, personally, I like to make, instead of 3 common bases, since this is multiplication, I can just divide by 2 to get rid of the multiplication and leave it with just an isolated exponent. So I would recommend doing that first. Then you can make a common base. If you did log, you would get the same answer, but I just think, try to make it easy and try to identify if you can do that. So there's the common base. Because 2 to the 3rd power is 8. And then from there, you would cross these off, and it would leave you with x minus 1 equals 3. So then you would add 1 to both sides, and x equals 4. So, like I said, at the end of class, after we do a little bit of notes for properties of logs, you will be given both quizzes. Quiz number 1 is on the basic, of logs. Quiz number 2, with a calculator, is on equations. You can retake them both, and we'll talk about retakes next week. Keep that in the back of your mind. So next thing up is notes. You're going to be given this packet, and I have another video. We are going to be doing what's called properties of logs. So we already talked about exponents have properties, things like that. Logs have different properties. So we're going to be adding them and subtracting them and stuff like that. The next video will have the notes, so you'll be handed out this packet.